Hello everyone, welcome to Vedanta JEE English. Okay, today we are going to be discussing all the PYQs which are related to the last week's topics, that is photons, photoelectric effect and atoms. So there are around 40 questions or something which I have picked. I have segregated them topic wise. You don't need to worry. For example, photons, and then we deal with only photoelectric effect questions, and then we are going to deal with de Broglie wavelength, and then we are going to deal with atoms. So I have segregated them topic wise. Let's go through them. Let's go through and let's see how and what type of questions, how many questions and what type of questions are coming. You'll get a rough idea about which subtopic is being preferred the most by the examinators, the one who is creating the paper, which subtopic they are going to be loving. We'll find out. Now, see, one thing is that right now there is MVSAT going on, right? It's a free test. You can give it online, you can give it offline. You can just enroll and write the test. There are many exciting prizes. You are going to be getting up to 100% scholarship also in the Vedanta courses. So as it is a free test, there is nothing you are going to lose. You just write it, register and write it. Okay, already I discussed about this. We are going to do this. Is our first question. This is our first question, and oh, okay, actually I have put which year it is. It's JEE Mains 2024 1st February evening shift. 1st February evening shift. Can I move this somewhere? No. Okay, let's not waste time. I will not waste your time. Look at the question. Monochromatic light of frequency 6 into 10 to the power 14 hertz is produced by a laser. The power emitted is 2 into 10 to the power minus 3, right? Now, how many photons per second on an average are emitted by this source? See, they gave the power. We know that the power is going to be energy divided by time, right? When you talk about averagely, yes, you can talk about energy by time. Now, if you talk about how much energy is going to be there, we know how much energy each photon will have. Each photon's energy multiplied with the total number of photons gives you. So, P is going to be the total number of photons into energy, which is h mu by T. So, N by T, man, trust me, if you know this is going to be helpful many times. See, many times you are going to come across questions where power will be given. And what is this E? Energy of photon. Energy of each photon, not the total energy. So now power divided by the energy is going to give you N by T. That's what you have to do. So the power is given. Power is given as how much? 2 into 10 to the power minus 3 divided by. And they gave the frequency, but they haven't given the energy of photon. So we can write h mu. So h value also we know it, right? They gave it 6.63 into 10 to the power minus 34 into mu. What's the mu? 6 into 10 to the power 14. So when you do the calculation of this, you are going to get roughly the value to be 5 into 10 to the power 15. And in all these questions, if you can't do the complete calculation, at least you see what is the power that is going to come. At least you see what is the power that is going to come and what will be multiplied to that power. For example, if 10 power 15 is going to be there, then to the 10 to the power 15, what will be multiplied? Is it less than 1 which is going to multiply? Is it going to be more than 1? So based on that, you can eliminate the options. So you don't need to do the exact calculations. Keep that in mind. Okay, next, one more question on the same thing, but slight extension, slight depth. Sorry. If the total energy transferred to a surface in time t is, they gave the total energy. Man, total energy is going to be what? The total energy is going to be the number of photons into energy of each photon or not? Yes. Into energy of each photon. They gave the total energy. Now what they are asking, magnitude of the total momentum delivered to this surface for complete absorption. See, if it is going to completely get absorbed. Now look, this is the surface. h by lambda momentum photon comes and strikes and it is coming to rest. So what is the change in momentum? H by lambda. It was having h by lambda. Now it became 0 because it got absorbed. So we can say the change in momentum magnitude wise is h by lambda. That is for each one. That is for each photon. But we have n photons striking, na? So the total change in momentum is going to be n times h by lambda. So how to get n times h by lambda from this given information? Energy of photon is what? Hc by lambda. So let us take this. When I take this one, the total energy is going to be n into hc by lambda. So n into h by lambda can be written as what? The total energy whatever they have given divided by c. Divided by c. See, total energy is this much and c is how much? 3 into 10 to the power. So I'll write it. Total energy 6.48 into 10 to the power 5 by 3 into 10 to the power 8. So you get 2.16 into 10 to the power minus 3. 2.16 into 10 to the power minus 3. Which option? It's A option. Right? So let us look at this. All these questions, more or less, you just need to know that total energy is going to be the number of photons into the energy of each photon. That gives you the total energy associated with the beam. If that energy divided by time, if you do, you get the power. If that power divided by area you do, then you get intensity. Okay. Two sources of light emit with a power of 200 watt. So both of them have same power. The ratio of number of photons of visible light emitted by each source having wavelengths 300 and 500 respectively. They are asking how many 300s and how many 500s are going to be there. So one light power can be written as what? Energy divided by time. Same story. Number of photons into hc by lambda is going to be the power. Now, one bulb is emitting 300 nanometers wavelength, other bulb is emitting 500, right? So if you look at, I will say the first bulb P1 is N1 by T into Hc by lambda 1. Now P2 is N2 by T into Hc by lambda 2. For your kind information, both of them are what? Same. P1 and P2 are same, right? So from there, what I can say? I can say N1 by T into Hc by lambda 1 should be equal to N2 by T into Hc by lambda 2. So Hc gets cancelled out. So N1 by T divided by N2 by T is going to be what? Lambda 1 by lambda 2. Lambda 1 by lambda 2. Lambda 1 is how much? 300. Lambda 2 is how much? 500. So you'll get it to be how much? 3 by 5. Ratio of number of photons of each source. I am taking this as my first source, this as my second source. Okay. Next. Which of the following phenomena does not explain the wave nature of light? Do you remember in wave optics? In wave optics, using Huygens wave theory, we were able to prove reflection. And using wave theory only, we explained diffraction. Photoelectric effect, wave theory can't explain. Interference is also what? Wave thingy only. Polarization is shown by transverse waves. So polarization is also shown by waves only, but transverse waves. Longitudinal waves don't show polarization. So these four are shown by the wave theory, or you can explain them with the wave theory. You can't explain photoelectric effect with wave theory. So what is the only option? They are asking which of the following phenomenon does not explain by wave nature? Only photoelectric effect. Only photoelectric effect. Rest all are explained by the wave theory. Okay. Now we are moving into photoelectric effect. UV light of 4.13 electron volt is incident on a photosensitive metal surface having work function 3.13 electron volt. The maximum kinetic energy of ejected photoelectrons. So what's the Einstein equation for photoelectric effect? Energy of the photon is going to be work function plus the Ke max, right? So what is the energy of the photon they are throwing? 4.13. What is the work function? 3.13. Then what can be the Ke max? The maximum Ke you can get. The Ke max you can get is going to be how much? 1 electron volt or not? Yes. So option B. Next. When UV light of wavelength 300 nanometer is incident on a metal surface having work function 2.13, the electron emission takes place. The stopping potential is, now they are not directly asking the Ke max, they are asking you to calculate stopping potential. So look again, what is the equation given by Einstein? Energy of the photon is what? Work function plus Ke max. But keep in mind, they are not asking the maximum kinetic energy of the electron, they are asking stopping potential. So if you talk about energy of photon, see they gave the Hc value. So you can say 1240 EV divided by 300. Nanometer gets cancelled out. Actually there is nanometer, right? So in the denominator also you will put nanometer, nanometer will get cancelled out. What is the work function? 2.13 electron volt, and maximum kinetic energy can be written as EV naught, where V naught is the stopping potential. Now look, I don't know. As students, you can do the calculations. I'm using calculator because I'm switching off my brain. As a teacher, I can do that. I can afford to do that. But students, you can't. So to sharpen the calculation power of yourself, you have to do these calculations. So from here, EV naught is 2 electron volt, because 4.13 electron volt minus 2.13 electron volt will give you 2 electron volt. E and E can be cancelled out. So from here, what is the stopping potential? Stopping potential is 2V. Stopping potential is 2V. Okay. Look at this chapter's questions. Photons, photoelectric effect, and for that matter even atoms also, they are very easy to score, so that's why these chapters you have to master them, and whatever the classes I have done are more than enough to solve all these questions. Not only these questions, the questions which have been asked in 2014-15, which are slightly difficult, which are more conceptual, I have gone way beyond the mains level and I have explained those things. So do check out. If you haven't completely watched the video, please watch the video. Even the handwritten class notes of me has been shared. Keep that in mind, right? So make a proper notes on your own also if you have time. If you don't have time, at least get the Xerox of whatever or the printout of whatever the notes that has been given from my side, whatever I have handwritten. Okay. In photoelectric effect experiment, energy of 2.48 electron volt eradicates a photosensitive material. The stopping potential was measured to be 0.5. Work function. Lilliput questions. I used to call, if something is going to be too easy, I call them Lilliput questions. What is the equation given by the Einstein? Energy of photon, work function plus Ke max. What is the energy of the photon? They said that it is 2.48 electron volt. What is the work function? I don't know. That is what they are asking to calculate. But what did they give? They gave the stopping potential to be what? 0.5. So Ke max is E times V naught. So E times 0.5 volt will be what? 0.5 EV. Then from here, you get it to be what? 1.98 electron volt or not. So where is 1.98? Option A. And when was this asked? JEE Mains 2024, 6th April, morning shift. So I was very precise on those shifts also, like which date, which shift. If I can get the data, I have put. Majority of the slides have this information. Okay. Which of the following statement is not true about stopping potential? See, if you remember all the graphs and all those things, stopping potential depends on the frequency of photon. Why? More the frequency, more is the energy. If more is the energy, then more will be the kinetic energy that will be coming out. Then you need more energy to stop it. That means you need more potential, or you can say you need more stopping potential. Okay. It depends upon the frequency of light. This is correct. And one more thing, man, you have to be very, very attentive whenever you see not. The moment you see not, na, in your scribble pad where you are going to be writing, you put cross. That means you have to mark the wrong one as your answer. So in all the options, you write the options. When these kind of questions are going to be given on the scribble pad, you write down the options. Then you mark which option is correct, which option is wrong, like this. Is option 1 correct? Yes. Now, it is 1 by E times the maximum kinetic energy of the emitted electrons. Yes, maximum kinetic energy is E times V naught, right? So V naught will be what? Ke by E or not? Yes, the second option is also correct. It increases with increase in intensity of the incident light. No, no matter how much you increase the intensity of light, if you are not changing the frequency, nothing is going to happen. Nothing is going to happen. So stopping potential depends only on the frequency. Without changing the frequency, if you increase the intensity, here intensity means number intensity, the number of photons that are going to be striking. So basically when they say intensity is going to be increased, in photoelectric effect, always keep in mind, if they don't mention what intensity, whether it is a watt intensity or number intensity, you default take it as number intensity. So when they say increase in intensity, instead of sending 200 photons, now we are sending 400 photons, but you are sending the same energy photons. So if you send same energy photons, then I already said to you, the stopping potential depends on the Ke max. Ke max depends on energy of photon. Okay, this is wrong. Next, it depends on the nature of emitter material. Yes, it depends. Why? Work function depends on material, na? So even if you send same energy photon, if work function is more, then less kinetic energy electron will come out. Less kinetic energy electron needs less stopping potential. So option 4 is correct. So 1, 2 and 4 are correct, 3 is wrong. So you have to mark which is not true. So C is not true. That's how you have to. Logically. Now look. Now look. Given below are two statements. Given below are two statements. Figure shows the variation of stopping potential with frequency for two photosensitive materials M1 and M2. The slope gives the value of H by E, where H is the Planck's constant. So stopping potential and frequency graph is given. Okay, we will talk about it. We will talk about it. Statement 2. M2 will emit photoelectrons of greater kinetic energy. See this one, statement 1, whether it is correct or not, let us verify that. Let us verify. It will be a small recap also for you. See, if I am going to talk about stopping potential versus frequency, you know that h mu, that is the energy of photon, is work function plus EV naught. So from here, you can write V naught as h by E mu minus phi by E. So what is plotted on y-axis? V naught is plotted on y-axis. For better understanding, whatever is plotted on y-axis, you write it as y. So y is equal to mx plus c. So it should be a straight line. How is that straight line? Like this. So who will decide this intercept? The negative intercept depends on the material. And what about the slope? The slope is h by e. So now let us go back. Sorry. Now let us go back. Now let us go back and see. Figure shows the variation, right? And said slope gives you h by e value. That means statement 1 is correct or not? Yes, statement 1 is correct. Now let us look at statement 2. Statement 2 says M2 will emit more photoelectrons. Man, who has more negative intercept? You extend these lines. Who will have more negative intercept? Obviously, M2 will have more negative intercept. If M2 is having more negative intercept, what does that mean? What does that mean? If M2 has more negative intercept, that means it has more work function. Let us draw this and draw this, right? You extend it. So when compared with M1, M2 has more negative intercept. That means the work function of M2 is going to be what? More than the work function of M1. That means if you send same intensity, if you send same not intensity, same frequency photons, that means same energy photons onto both the metals, if you send same energy photons, as work function is more for M2, less kinetic energy will be there for the electrons coming out of M2. But what did the statement say? M2 will emit photoelectrons of greater kinetic energy for the incident radiation having same frequency. Man, same frequency means same energy photon is striking. Same energy photon is striking. So if same energy photon is striking both of them, whichever has more work function, that will have less kinetic energy. But they gave what? They gave more. That means statement 2 is what? Wrong. So which statement 1 is correct and statement 2 is incorrect? So the answer for this question is A. Answer for this question is A. Okay. Next. One more theoretical kind of question. Given below are two statements. One is labeled as assertion A and the other is labeled as reason capital R. Okay. Assertion A, number of photons increases with increase in frequency of light. Next statement, maximum kinetic energy of emitted electrons increases with frequency of incident radiation. You tell me, is the reason correct or not? Like, don't talk about assertion. First, let us talk about just reason. Alone, if you read reason, is it correct or not? Maximum KE of emitted photoelectrons increases with the frequency of incident radiation. That is correct. Why? If you increase the energy of the incident one, if you increase the energy of incident photon, obviously work function is constant. So the kinetic energy of the electrons coming out will be more. So R is definitely correct. So R is correct. Now let us go for A, whether it is correct or not. Number of photons increases with increase in frequency of light. Man, do you think it is going to be proper to say like that? They have to mention whether the source is having same power or not. If it is going to be having same power, if the power is not going to be changed, then what will happen? If you increase frequency, actually the number of photons should decrease. Why? Look, power can be written as what? Power can be written as what? N by T, that is the number of photons coming out per unit time into energy of each photon. So if you maintain same power source, which is not given in the question, that's what happens in JEE mains sometimes. So there you have to use your common sense. I'm assuming that they are talking about a constant power source. Then if you increase the frequency, the energy will increase. So N by T is going to be what? That power divided by E. Power divided by E. So you have maintained same power, but you increase the frequency. As a result, energy will increase. That means denominator is increasing. That means the number of photons coming out per unit time, they will decrease. So I will claim that A is not correct. But according to me, it's an ambiguous question. Just because it is JEE means I have taken the liberty of giving you answer, but it's ambiguous. Why? They mentioned that the power of the source which is generating the photons, never they mentioned that it is having constant power. But I assumed it, what to do? Okay. So if you talk about a constant power one, if you are trying to increase the frequency of photons coming out from this power, then automatically the number of photons will go down. Number of photons will go down. The number intensity will go down. Okay. Which figure shows the correct variation of applied potential difference V with photoelectric current I at two different intensities of light, I1 less than I2 of same wavelength? That means they are talking about same frequency. If they have same frequency, stopping potential should be same. Which graph has same stopping potential? This is the only graph having same stopping potential. Done. Because stopping potential doesn't depend on intensity, stopping potential will depend only on frequency of light that you have thrown onto the metal surface. Okay, done. In a photoelectric effect experiment, a light of frequency 1.5 times the threshold frequency is made to fall on the surface of photosensitive material. Now if the frequency is halved and intensity is doubled, see, they're just trying to just beat around the bush. They're trying to beat around the bush. Lot of data they are giving just to mislead you. See, they are saying intensity is doubled. Unnecessary data. You will understand why I said it is unnecessary. Man, the minimum frequency for which photoelectric effect takes place is threshold frequency. Now, if the frequency what you are throwing is 1.5 times the threshold frequency, will photoelectric effect take place? Yes, pakka photoelectric effect will take place. No doubt in that. But now look, now if the frequency is halved, that means, let's say they are throwing 1.5 in the beginning, right? Now they made it half. So if it is halved, 3 by 2 mu by 2 will become what? 3 by 4 mu th. So this is what? Less than the threshold frequency. The moment you realize that the frequency has become half, the moment you realize that it is less than the threshold frequency, arey man, why to bother about the intensity? Unnecessary data. I can clearly see that the frequency is less than the threshold frequency. If it is less than the threshold frequency, photons are not going to be emitted. So how many photons will come? Zero. No photoelectric effect only. There is no photoelectric effect. So see, unnecessary data they put in sometimes just to confuse you. If you are conceptually clear, you don't need to worry about the unnecessary data. You can just think that, okay, this is the data I need. Okay, they have given additional data, might be just to confuse us. That's it. That's how you have to think. Okay. Next. When a metal surface is illuminated by light of wavelength lambda, the stopping potential is 8 electron volt. Okay, fine. When the same surface is illuminated by a light of wavelength 3 lambda, the stopping potential is 2. And they're asking threshold wavelength for this surface is. Okay, a bit of calculation. See, same story given by Einstein. What is that? Energy of photon is going to be work function plus the Ke max. And that Ke max can be written as EV naught. Don't forget that. And they gave stopping potentials only, I think. Yes, they gave stopping potentials only. Now look, they have given two data points. From those two data points, we will get two equations. How? Look, energy of photon. I can write hc by, first they have thrown lambda. Work function, you keep it as it is. What is the Ke max? 8 EV. And then hc by, now they have struck with 3 lambda. So work function plus 2 EV because the stopping potential is 2 now. If I can calculate the work function, work function is hc by lambda threshold. Keep in mind, work function is h mu th or hc by lambda th or threshold wavelength. So from this, can we calculate the phi value? Easily we can do that. So you multiply this 3 to this side, then what will happen? the Hc by lambda is going to be 3 phi plus 6 eV. So from here, you put this over here, then you get it to be what? 3 phi plus 6 eV plus 6 eV is equal to what? 5 plus 8 eV. Now you only tell me, what do you get the work function as? You get it as 1 eV. You get it as 1 eV, 1 electron volt. So you put that 1 electron volt over here. If you put that 1 electron volt over here, Hc by lambda is equal to 9 electron volts. Right? Okay. So if I put it back over here, then what am I going to get? I will get the Hc by lambda to be equal to what? To be equal to 9 eV. So I can write work function as what? 1 eV, right? 1 eV can be written as what? Hc by 9 lambda. And work function can be written as Hc by threshold wavelength, which is going to be Hc by 9 lambda. So Hc gets cancelled out, threshold wavelength will be 9 lambda. So threshold wavelength will be how much? 9 lambda. So just two equations and we solve them, we get the work function. When we get the work function, you put it back, then you get to know the Hc by value, Hc by lambda value, and then you put work function. Work function is in electron volts, right? So 1 electron volt. So from here, what is 1 electron volt? Hc by 9 lambda. Put it Hc by 9 lambda, and work function can also be written as Hc by threshold wavelength. Done. Threshold wavelength is 9 lambda. Okay. Now, further, for the photoelectric effect, the maximum kinetic energy Ek of the photoelectrons is plotted against the frequency. They have changed the graph. What was the graph which we were doing till now? Like even in the theory classes or in the questions also, we were drawing a graph between stopping potential and frequency. But now they are not asking us to draw a graph between stopping potential and frequency. They are asking us to plot a graph between kinetic energy and the frequency. Okay, and then they are talking about slope. So let us do that. First of all, Hc by not Hc. Why? We have to talk about frequency. Energy of the photon is work function plus the kinetic energy max, and h mu is going to be what? 5 plus this. They wrote it as Ek. So from here, Ek is going to be what? H mu minus 5. This is what is plotted on y-axis. Mu is plotted on x. So I can say it as y is equal to mx plus c. So here the slope is going to give. Here the slope is going to give Planck's constant, and c is going to give you the the negative intercept is going to give you work function. But in the question, they are talking about slope. Slope is what? Let's go back. What is slope? Planck's constant. So what you are going to mark? Planck's constant. Done. Okay. Next. Again, see how many questions have come only on photoelectric effect. So if you ask me a question, sir, which is more important out of photons and photoelectric effect? The photon theory is less important than the photoelectric effect. Photoelectric effect is very, very, very important. Okay. Work function of a substance is 3 electron volts. The longest wavelength of light that can cause the emission of photoelectrons from this substance is, man, longest wavelength is nothing but called as threshold wavelength, because they are talking about photoelectric effect to happen. So they gave work function. So work function is how much? 3 electron volt. And that work function can be written as Hc by threshold wavelength, and that Hc can be written as 1240 eV nanometer by threshold wavelength is going to be 3 eV. EV can be cancelled out, so the threshold wavelength is going to be 1240 by 3 nanometers. So 1240 divided by 3. 1240 divided by 3 gives us 413.33. So which option is closer? Yes, this is closer. 414. So your answer is going to be what? C. Okay. Next. Again, similar question, but instead of asking threshold wavelength, they are asking threshold frequency. So the threshold frequency of a metal with work function 6.63 eV. So now what I should write? I should go for the frequency, right? I know how to calculate the wavelength, right? So because I have a ready-made formula. So 1240 eV nanometer divided by lambda gives you 6.63 eV. So directly from here I'll get the lambda, which is going to be 1240 divided by 6.63. See, some people might be thinking, sir, why to do this much? I'll give you one more way also. Don't worry, I'll give you one more way. I'm just giving you in this format. So wavelength is coming out to be how much? 1240 divided by 6.63 gives you 187. So the lambda is around 187 nanometer. But this is not what they asked. They asked the frequency associated with this one. They asked frequency. So the frequency is going to be what? C by lambda. So it is 3 into 10 to the power 8 divided by 187 into 10 to the power minus 9. So if you add, then you can say, like if you take it up, 10 to the power 2, you multiply it to 3, it will become 300 by 187 is going to be 1700, 10 to the power 15. So 180 by 300 by 187. 300 divided by 187, which is 1.6. So 1.6 into 10 to the power 15. Some people will be like, sir, isn't it pointing the nose like this? Can't we go in any other way? Can't we go in any other way? Is this the only way of doing it? No, there is one more way. That is, see, they gave work function as 6.63 electron volts, which can be written as 1.6 into 10 to the power minus 19 joules. Electron volt is 1.6 into 10 to the power minus 19 joules. Now this can be written as h mu. And what is the h? What is the h value? It is 6.626, but let's write 6.63 into 10 to the power minus 34. Are we getting the mu value directly or not? Yes, we get it directly. But sir, why did you do it in both the ways? Like, why did you do it in this way? Why did you do it in this way? I'm just trying to show you that if they have asked for threshold wavelength, this is how you proceed. If you get the threshold wavelength, you can get threshold frequency also. Or directly you can start with the frequency one, but keep in mind that electron volts should be converted to joules, because when you are going to put H, the SI unit form of H, then definitely the energy should also be in the form of SI units, which is joules. That conversion you have to keep in mind. Okay. With this, we are done with the questions of photoelectric effect. After that, what did we learn? De Broglie wavelength or not? Man, de Broglie wavelength is very, very, very small. De Broglie wavelength is very small, right? But the amount of questions are very high. Let's see. See, given below two statements, one is labeled as assertion and the other is labeled as reason. Assertion A beam of electrons show wave nature and exhibit interference and diffraction pattern. Is it true or not? Electron also behaves as a wave. Matter also can behave as a wave. In fact, people have done YDSC experiment with electrons and they got interference pattern. And one more famous experiment was Davison and Germer experiment. Davison and Germer did an experiment with electrons and the electrons have shown the diffraction pattern. Electrons have shown the diffraction pattern. That's how experimentally people established that electrons have wave nature, and which strengthened the theory proposed by de Broglie. So first statement is correct. Davison and Germer experimentally verified the wave nature of electrons. Both of them are true only, na? So The beam of electrons show wave nature and exhibit. See why they are able to show diffraction pattern? Because they have wave nature, right? Okay. Davis and German experiment verified the wave nature of electrons. Those are two independent statements, right? So this is where correct explanation and not correct explanation are going to be kicking in. Not only you, I'm being honest and I'm being blunt, right? People can't guess what they are going to give as answer, but I have one way. That way is going to be, if the first statement is directly explained by the second statement, you mark it as a correct explanation. If not, you mark it as a not explanation, right? So don't change the way you look at the question just because answer is given as something else. I don't care about the answer. See, read the first one. The beam of electrons show wave nature and exhibit interference and diffraction. And second is, it's just a fact. How this first statement is explained by the second statement? No, right? That is why I will go with not an explanation. I don't care about the answer given. Okay. Next, a proton, an electron, and an alpha particle have the same energies. When they say same energies, their intensity is same kinetic energy. Okay. Their de Broglie wavelengths will be compared as like which one is having more, which one is having less. Man, we have the de Broglie wavelength to be h by root 2mk, right? So if all of them have same kinetic energy, Planck's constant is anyway same. 2 is also a constant which is anyway same for all of them. So can I directly claim that the de Broglie wavelength is inversely proportional to root m, or you can say more the mass, less is the de Broglie wavelength. Which one is having more mass, man? Alpha will have, then proton will have, then last we have electron. More mass is for alpha. Then the alpha one will have less de Broglie wavelength, and then proton, and then you can say electron. Whichever has less mass will have more de Broglie if kinetic energy is going to be constant. So which option? The lambda E should be more, and then we should have lambda P. So yes, B option. Lambda alpha less than lambda P less than lambda E. That's it. Next, a proton and an electron have same de Broglie wavelength. Oh, they said same de Broglie wavelength. Fine. If Kp and Ke be the kinetic energies of the proton and electron respectively, then choose the correct relation. Come on, man. How many times? It's one formula and we keep coming across that. Now look, the lambda, they only said it is same for both of them. So lambda is same, h is anyway same, 2 is anyway same. So can I say that m into Ke should be constant or it should be same? Right? So if I am going to talk about Ke of the proton by Ke of the electron, it is going to be mass of the electron by mass of the proton. Or you can say directly from here, the kinetic energy they have is going to be inversely proportional to the mass. So whichever is going to have less mass will have more kinetic energy if de Broglie wavelengths are same. Who is going to have less mass? Electron is going to have less mass. So Ke, kinetic energy of E, will be more than the kinetic energy of proton. Next, a proton and an electron are associated with same de Broglie wavelength. Ratio of their kinetic energies. Just now I did, na? See what ratio they are talking about. First is proton, next is electron. Just let us go back to this slide. How is the ratio? Kinetic energy of proton to kinetic energy of electron can be written as mass of electron by mass of proton. So let us write that. So the kinetic energy of proton by the kinetic energy of electron is going to be mass of the electron by mass of the proton. What is mass of the electron? It's 9 into 10 to the power. Oh, we don't need to. Why? I'll tell you. You just write it as Me only. But what did they say mass of proton as? 1836 times the mass of the electron. Then this and this gets cancelled out. So the ratio is what? 1 is to 1836. 1 is to 1836. So which option? Option C. Okay. Next. De Broglie wavelengths of a proton and an alpha particle are lambda and 2 lambda respectively. Ratio of velocities of proton and alpha particle will be. Man, they are talking about velocities, not kinetic energy. So use De Broglie wavelength formula as h by mv. So lambda is going to be what? H by mv. And lambda is given for whom? Proton. So mp vp. Now 2 lambda is going to be h by mass of alpha, speed of alpha. Now can I put the lambda here? Yes. What is the lambda? H by mass of proton, speed of proton is going to be h by mass of alpha, speed of alpha. H and h are going to get cancelled out. Now what they are asking, ratio of velocities, Vp by V alpha they are asking. So I'll take Vp this side and I'll keep V alpha on the same side. Now m alpha, if I'm going to take it to this side, 2 times the mass of alpha by mass of proton. So mass of alpha is going to be 4 times the mass of proton, right? Divided by mp. So mp gets cancelled out. 2 into 4 will be how much? 8. So it is 8 is to 1. It is 8 is to 1. Okay. Next, de Broglie wavelength of an electron is same as that of a photon. Okay. If the velocity of electron is 25% of the velocity of light, the ratio of kinetic energy of electron to the kinetic energy of photon will be. Man, rather than using the word kinetic energy of photon, if they have simply said energy of photon, that would be more suited, more suitable for photon. Okay, still, what is energy of photon, man? Hc by lambda. Energy of photon is hc by lambda. That you can't play with. Energy of photon is going to be given by hc by lambda, where lambda is the wavelength of that photon. Now what did they say? The de Broglie wavelength is same. That means same lambda is there. Is going to be what? H by mv. And what is the v value they have given? The v is 25% of velocity of light. That means you can say this to be h by m into c by 4. So just keep this in mind. M into c by 4 is h by lambda. Just keep this in mind. And what is m into c by 4? Momentum of that electron. Momentum of the electron. Now let us talk about the kinetic energy of the electron. The kinetic energy of electron can be written as what? Momentum square divided by 2m, right? Right or wrong? Okay. What is that momentum square? H square by lambda square. H square by lambda square divided by 2 times the mass of electron. But look, if you want to compare the energies, even mass should not be present. Even mass should not be present. Now let us go back to the very same thing. Mass can be written as what? H by lambda by c by 4. So the Ke can be written as what? H square by lambda square divided by 2 times. What is the mass of the electron? H by, or you can say 4h by c lambda. 4h by c lambda. 1h, 1h, 1 lambda, 1 lambda. Now the c goes up. So the kinetic energy of the electron is hc by 8 lambda. And what is the energy of the photon? It is hc by lambda. Now look at the ratio. Is it 1 is to 8 or not? Yes. So the ratio is 1:8. Okay. So I just followed the data what those people have given, man. I didn't create anything. Whatever the data they have given, I was just blindly following it. And for your kind information, all these questions I am straight away doing right in front of you. I haven't prepared before and come. If I have prepared before, na, the disadvantage is going to be I already know the answer. So as I already try it, na, as I am going to be already as I have already done it, my brain will go automatically for the shortest process. So every PYQ discussion, whatever I am going to do, is going to be a raw discussion. Raw discussion in the sense these questions I'll just directly put into PPTs. I'll come into the class right in front of your eyes. I'll do it. Whatever I feel, I will say that. That's it. Conceptually, I'm never going to be wrong. Keep that in mind. You can blindly trust me on the concept. Sometimes I might be doing calculation mistakes, but conceptually never I will do a mistake. And just because answer is given something in the book, I will never change my answer if I can't find fault with my approach. That's how you should be also. That's how you should be also. Best example, there was one assertion reason thingy, right? What did I say? First statement, second statement. If I can't see it to be a direct explanation, I'll say it is not an explanation. Let them give whatever the answer they want. Right? Because sometimes they are going to give that it is not an explanation. Sometimes they'll give that it is an explanation. So because of that, you just tend to confuse. You don't need to. Because the paper setter is having a problem, not us. So if you see it to be a direct explanation, only then you mark it. That's how my nature is going to be. That's all, and that's how you should also be. Always, whenever there is a question and if the answer is not matching, check your calculations. If the calculations are not wrong, then you should be like this. Might be they are wrong. I am not wrong. So when you get that level of confidence, when you are conceptually strong, when you know what you are writing, when you know what you are doing, that's how you should become in physics. I am like that. As I am teaching you, you will definitely become like that. Okay. Given below are two statements. Statement 1, most of the mass of the atom and all its positive charge are concentrated in a tiny nucleus and the electrons revolve around it. Is Rutherford's model. Yes, that fellow, he gave that only. That's what alpha scattering experiment has proved. Now let us go for statement 2. Whenever I see statement 1, statement 2, correct explanation, wrong explanation, I'll be very frustrated with that. Okay, an atom is a spherical cloud of positive charges with electrons embedded in it. Come on, man. That's not what Rutherford has said, right? Rutherford said that the whole positive charge is concentrated at one location and electrons revolve around the nucleus, not the positive charge spread over throughout the volume. Statement 2 is definitely wrong. I am the most happiest person for this question. Why? One statement is definitely wrong, na? So I can easily mark. No need to bother about correct explanation or not a correct explanation. Okay, fine. Okay, here options also are good. No explanation kind of thing. Statement 1 is true, statement 2 is false, so option B. So option B. Okay, next. So by now you should have realized that we have entered into atomic physics. That's the reason why we dealt with the Rutherford model question. Now, a hydrogen atom in ground state is given an energy of 10.2 electron volt. How many spectral lines will be emitted due to transition of the electron? If you give 10.2, where it will go, man? See, this is your n is equal to 1 having an energy of minus 13.6. And this is your n is equal to 2 having an energy of minus 3.4. So the energy gap between them is 10.2. That means the electron whatever is going to be existing here, if it is given 10.2 electron volt, where it goes? Obviously it goes here. Now when it is going to de-excite, it has only one place to go, that is this. So how many will come? Only one photon will be emitted, right? When it is de-exciting, only one photon is going to be emitted. That photon will have one wavelength. That wavelength will belong to one particular vertical line in the spectrum. So you get only one spectral line. So answer is 1. When did they ask? 2024, 9th April, evening shift. Next. The longest wavelength associated with Passion series is, look, whenever they talk about longest wavelength, That means the energy of photon that is going to be coming out should be lowest. Energy of photon being lowest means lowest energy gap. Passion is going to be when the de-excitation happens to n is equal to 3. So we have n is equal to 4, we have n is equal to 5, we have n is equal to 6. But if you are going to go for higher energy levels and de-excitation from there, if we go for higher energy levels and de-excitation from there, the energy gap will be more. So more energy photon will come out. If more energy photon is going to be coming out, wavelength will be less. If you want longest wavelength, the transition should be between two successive energy levels. That means the electron should jump from here to here. They gave Rydberg's constant. So I'll use this formula. 1 by lambda is going to be Rydberg's constant into 1 by n1 square minus 1 by n2 square. I know the n1 value, I know the n2 value. See, from 4, it should come to 3. So I can say r into 1 by 3 square 9 minus 1 by 4 square 16. So the lambda value is going to be how much? 9 into 16 by 7r. That's it. So I'll just use calculator, man. 9 into 16 divided by 7 is 20.57 divided by 1.097. So 18. 1/8 should be there. That means this option. Option B. 1/8 should be there. So I have chosen the option B because there is no other option having 1 and 8 involved in them. Next. Ratio of shortest wavelength. Man, whenever they say shortest wavelength means maximum energy photon. Maximum energy photon means what? Maximum energy gap. So from a particular level, maximum energy gap will be with the level which is at infinity. So okay, ratio of shortest wavelength in Balmer series to that of the wavelength in Lyman series. Lyman series means de-excitation is going to be 2, n is equal to 1. Okay, look man. So first we will talk about Lyman series, and in fact that's your lambda 2 because ratio of Balmer to Lyman is what they have asked. So Balmer de-excitation should happen to n is equal to 2. From where? From n is equal to infinity. So in this case 1 by lambda 1 will be what? R into 1 by 4 minus 1 by infinity square. So you are going to get 1 by lambda 1 as R by 4, man. R by 4. Now in the Lyman series, the de-excitation is going to be to n is equal to 1. This is n is equal to infinity. When the de-excitation happens like this, then 1 by lambda 2 is going to be R into 1 by 1 square minus 1 by infinity square. So 1 by lambda 2 is what? Is equal to R. So this is your equation 1, this is your equation 2. But I need lambda 1 by lambda 2. So what I'll do is equation 2 divided by equation 1. Equation 2 divided by equation 1 will give you what? 1 by lambda 2 divided by 1 by lambda 1 is going to be what? R by 4. So lambda 1 by lambda 2 is going to be 4 times. So the ratio of Balmer to the ratio of Lyman will be 4:1. Okay. Angular momentum of an electron in a hydrogen atom is proportional to. See, we know angular momentum is going to be nh by 2 pi, but they didn't give in terms of n. They are comparing it in terms of r. Okay, I know angular momentum to be what? nh by 2 pi. And I also know that radius is proportional to n square. By g I won't write. By z I won't write because anyway they are talking about hydrogen. So z is going to be 1. Then from here, can I say n is proportional to root r? So in this case, can I say L is proportional to n and that n is proportional to what? Root r. So the angular momentum is proportional to what? Root r. The angular momentum is proportional to root r. That's it. It's just playing around with these things. That's it. According to Bohr's theory, the momentum of an electron revolving in, man, moment of momentum is also called as angular momentum. Angular momentum. See, when we talk about angular momentum is going to be what? NH by 2 pi. So moment of momentum is nothing but angular momentum. In which orbit? Fourth orbit. So you put 4 into h by 2 pi, which will turn out to be what? 2h by pi. So the angular momentum is going to be 2h by pi. Okay. The minimum energy required by a hydrogen atom in ground state to emit radiation in Balmer series. This question is slightly good. Man, let me draw the energy levels. For example, this is n is equal to 1, this is n is equal to 2, this is n is equal to 3, this is n is equal to 4, this is n is equal to 5. For emission to be in Balmer series, definitely finally electron, whatever the electron I am talking about, it should definitely de-excite to n is equal to 2. That means whatever the energy you supply to the electron in the ground state, let me write it. The electron in the ground state, if I give 10.2, it will exactly reach n is equal to 2. It will exactly reach n is equal to 2. Then de-excitation won't happen. Won't happen to n is equal to 2. De-excitation possible from 2 to 1 now. But if I give an energy which is going to make it reach here, what is that energy needed? 12.09. If I give 12.09 electron volt of energy, then it goes to n is equal to 3. Then there is a possibility of it de-exciting to n is equal to 2. And in fact, this is your Balmer series line. So when de-excitation happens to n is equal to 2, that's when we call it to be in Balmer series. So for de-excitation to happen to 2, at least an electron should be in third state. At least it should go to third. So that means the least energy you have to give is to make it go to the third. Because to make it go to the fourth, you need to give more energy. But they are talking about minimum energy. That means the energy you supply to this should make it go to n is equal to 3. So search for 12.09. This 12.1. So if you give 12.1, the electron in the ground state goes to n is equal to 3. When coming down, yes, it can de-excite to n is equal to 2, and you get a photon in the Balmer series. Good. This is a good question. Next. If the wavelength of the first member of Lyman series of hydrogen is lambda, the wavelength of the second member will be, see, this one, to be honest, I want to do it, but man, it is just a formula application. So I am leaving it to you. Anyway, they said that it is obviously Lyman, all those things are defined for hydrogen. So the G is going to be whatever is going to be there, you can put it as 1. You have to just use this formula. Right? And whenever it is going to be Lyman series, definitely you know N1 also to be 1. So 1 by lambda is going to be R into 1 by 1 square minus, now you have to put the N2 values. 2 to 1, 3 to 1, 2 to 1, 3 to 1, 4 to 1, like that you have many different transitions, right? N is equal to 1, n is equal to 2, n is equal to 3, and so on, right? You'll have transition like this, photon like this, one photon will come like this, one photon will come like this, one photon will come. Now they are comparing the first two. That's it. An electron revolving in nth Bohr orbit has magnetic moment mu n. Okay. If mu n is going to be proportional to n to the power x, the value of x is, man, there are two ways to do this. One way is going to be a shortcut which you people would have come in electromagnetism. Magnetic moment by angular momentum is going to be charged by 2m. I don't know whether you remember this or not. Magnetic moment by angular momentum is going to be given by q by 2m, this relation. And it was an important thing also. Q is nothing but the charge. So what is the charge which is revolving over here? Electron. You can put it as minus m, mass of the electron. So they are anyway constants. So we can say that the magnitude of the magnetic moment is directly proportional to the angular momentum. And that magnetic moment only they are representing with mu. So I'll represent that with mu. It's proportional to angular momentum. And we know angular momentum is nh by 2 pi. So angular momentum is proportional to what? N. So mu should also be proportional to what? N. So mu is proportional to n to the power 1. That means the x value is what? 1. This is direct way of getting to it. If you know this, you would have answered in seconds. You would have answered. Some people will be like, sir, I don't know this one. Then in that situation, how do I approach it, sir? Man, one more way of magnetic moment is going to be what? If you remember, NIA. Here we have only one electron, so there won't be multiple loops. So the magnetic moment represented with mu is going to be I into area of the loop, which is pi Rn square. I is going to be what? The charge divided by the time period, right? Pi Rn square. And then time period can be written as what? 2 pi Rn divided by Vn into pi Rn square. 1 Rn can be cancelled out. So what is happening? The mu is q by 2 into Vn Rn. Right? Now you tell me the mu is proportional to, look, Vn. Vn is proportional to what? G by n. And Rn is proportional to what? N square by G. So from here mu will be proportional to what? N. It's up to you how you want to approach. That's not a big deal. It's up to you how you want to approach. It's not a big deal. Keep that in mind. So if you know this one, you would have got the answer directly. And yes, you will be made to mug this one up because this will be very useful in solving some questions. Like there will be a sphere rotated, there will be a disc rotated, there will be a ring rotated. Then they'll talk about the magnetic moments of those things. If you don't know this one, then you have to use integration. That's why they'll teach you this. Okay. Next, let us talk about energies. An electron rotates in a circle around a nucleus having positive charge JE. The correct relation between a total energy of electron to its potential energy. Not only over here, man, I'm giving you in general. If the force that is going to be acting is inversely proportional to distance square, and if it is going to be a circular orbit, then the total energy will be minus of kinetic energy or half of potential energy. There is a reason why I am saying this to you. Reason being, in gravitation, satellites will move around Earth. What is the force on the satellite? Gravitational force of attraction. And the gravitational force of attraction is proportional to 1 by r square or not. And satellites are moving in circular orbits. So even there also, if you look at, you get the same thing. Now they said that the total energy is what? They said that the total energy is represented with E. So E is going to be what? U by 2. So we can say 2E is equal to what? U. So 2E is equal to what? U. That's it. Okay. Next, ratio of the magnitude of kinetic energy to the potential energy of an electron in the fifth excited state of hydrogen. Array, fifth excited state has been given just to confuse you. Just to confuse you. Whether it is fifth, whether it is sixth, whether it is 10th, or whether it is infinite, whatever it is. Whatever it is. I'm telling you, right? The total energy is minus of kinetic energy is half of potential energy. Right? Now they are asking what? Ratio of kinetic energy to potential energy. So you write that the kinetic energy to the potential energy is going to be what? Minus 1 by 2. Is minus 1 by 2 given in the options? No. Then you mark the magnitude. Might be they are talking about magnitude of energies. Ratio of magnitude of energies. But in reality, proper ratio will be minus half. Reason being, one will be positive, one will be negative. Okay. Next. I think mostly we are at the end. Around 40-50 questions were only there. Radius of third stationary orbit of electron for Bohr's atom is capital R. Radius of fourth stationary orbit is, man, we know that the radius is proportional to n square by g. So radius of the third, R3, by R4 will be automatically 3 square divided by 4 square. I won't bother about the G because we are talking about the same atom. In the same atom, third and fourth are compared. So in that case, R3, 1 second. R3 is given as what? Capital R. R4 we have to calculate. And this is 9 and this is 16. Then what will be the R4 value? The R4 value is 16 into R divided by 9. So which option? 16 into R divided by 9. Okay. Yes. So with this, we are done with all the JEE 2024 questions that have been asked. All the JEE 2024 questions that have been asked. And this Monday, we are going to start waves chapter, and you will have class at 5 o'clock. Be ready. I'm going to come with some animations and some simulations. With the help of simulations, I'll make you visualize how the waves are going to look like. I'll definitely guarantee you that the way you were looking at waves after the class which I'm going to take, the way you are going to look at the waves will be to the next level. You can say to the power infinity. That much conceptual clarity you are going to get. I can make you feel how the particles will move, what is exactly happening, right? So waves is never going to be no longer, I won't say never going to be, waves after my class is no longer going to be a difficult chapter for you. Trust me on that. Stay tuned for Monday's class. All the best. Keep working hard.